And for our final video for this lesson, we are going to learn the converses of a couple of theorems that we learned earlier. The first one is the converse of the perpendicular bisector theorem, which says that if a point is equidistant from the endpoints of a segment, it is on the perpendicular bisector of the segment. So in other words, if segment AP and segment BP are congruent, or those distances are equal, then segment PQ is perpendicular to segment AB, and segment AQ is congruent to segment BQ. Now the way this works is using the hypotenuse leg theorem, because if you notice, segment AP and segment BP are hypotenuses of two right triangles. And segment PQ is the leg to those same two right triangles. Now, we can do this, we can say that we have right triangles because when we construct segment PQ, we can construct it with one condition. So we'll construct it saying that it is perpendicular to segment AB, because we can draw a perpendicular segment through any point. That's generally the idea behind the proof. So when it's asked, say, on a mastery check, on an assignment, on a mastery assessment, you have an idea of how it's going. The other converse we are learning is the converse of the angle bisector theorem. That says that if a point is equidistant from the sides of the angle, then it is on the angle bisector. In other words, if PU is equal to PG and PU is perpendicular to ray VU and segment PG is perpendicular to ray VG, then point P, then ray VP bisects angle GVU. So those are our converses. Let's take a look at how we can use them. A civil engineer is designing a new park. She wants to place a gazebo equidistant from the pond and the fountain. Where are possible locations for the gazebo? Explain. Now, you don't even need to know what a gazebo is here. All that you need to know is that we need it to be equidistant from the fountain and the pond. Shall we call those points F and P? And so we can draw a segment joining those 2 points. Now, she wants it equidistant from those points, those end points. If a point is equidistant from the end points, then it is on the perpendicular bisector. So our civil engineer is going to have to put their compass at point P, draw an arc, move the compass to point F, draw another arc, and voila, line G here is the perpendicular bisector of segment FP, which means that she can place a gazebo anywhere along line G, and she will have a gazebo equidistant from the fountain and the pond. Okay, so basically, since we get an answer similar to that. Now let's take a look at the converse of the angle bisector theorem. Oh geez, we want point K to be on the angle bisector. How are we going to do that? Well, we are going to ensure that BK is equal to SK. That's the converse of the angle bisector theorem. So therefore, we can write an equation by substituting in the values for BK and SK. We can subtract 3g from both sides of the equation. We can add 24 to both sides of the equation, and then we can divide both sides of the equation by 7. So g has to equal 6 in order to make point K on the angle bisector of angle BHS. There you go. Try a couple more problems on your own, and then you are ready for class.